For example, I am trying to take two numbers. One is plus 45, another one is plus 62. How we are going to perform addition of these two numbers? First, what is the result of these two? Assume that they are in base 10, right? If they are not in base 10, can I assume that they are in base 7? Can I assume or not? Yes, because they are going to be valid. So they have given specifically they are in base 10, so they are also valid. Now what is the result of this one? Plus 107 base 10. 107 base 10, right? So in unsigned number system, what you are going to basically do? You are going to simply take 45 and convert it into binary number. What is the binary number of 45? 32 and 16. 32 and 16 is 48, which is greater than 45. So I can take it as 0. And then I can consider it as 1, that is 8. 32 and 8 is 40. And then 4, 44 and 0, 1. This is the binary number of 45. And if you take 62, I think 32 and 18, 40, 48. Okay, 48 plus 4, 52. 52, and I think any mistake is there. So 32 plus 16 is 48. 48 plus 8 is 56. 56 plus 4 is 60. 60 plus 2 is 62, followed by 0, which means total number is 62, right? If you are going to add these two numbers, what is the result you are going to get? 101, 1, 1, 1 is 10. What is triple 1? 1 plus 1 is 10, plus 1 is 1, 1. Double 1 is 10, 10, right? So what is the total number? Last is 1, 1. Okay, 1, 1. Right? What is the total number? This it is equivalent to 1, 2, 4, 8, 16, 32, 64. 64 plus 32 and so on. If you are going to calculate, you are going to get 107 base 10. 107 base 10. Right here, I will raise one question for you. Try to observe if it is in 6-bit system. If it is in 6-bit system, how much memory is available for me? 6 bits. What is the result I got? 7 bits. Meaning that, is there any position to save this number 1? No. At the time, what is the result you are going to get? You are going to get minus 64, you are going to get something around 43, which is incorrect result, right? So there is no problem here in normal binary operating system. Binary system. So right now we can consider as 107 base 10. Okay. Try to observe one more point. I am trying to take two numbers. One is 45 base 10. Another one is 62 base 10. I am trying to perform difference. Now, how we are going to perform the calculation? So you are going to do with first 9's complement, or you can do it with 10's complement. You can do that, right? This is what you have seen in earlier class also. 45 is basically 101101. 62 is basically component, like complement. Complement of 962 is okay. Fine. You can follow any of the procedure, right? So I think we have seen this particular procedure. 45 base 10, and you are trying to find out the 9's complement of 62. That is 37. You are going to get sum, right? 5 plus 7 is 12. 4 plus 3 is 7. So total you are going to get 82. 82, right? So 82 is what? X minus y. X minus y, right? You need to get the result of what? 17. How we are going to get it? By using once again 9's complement. 99. Then you are going to get 17. This is minus 17 because you are trying to find out the complement. That is minus of x minus 1 is 17. So x minus y is 17. Minus 17. X minus y is minus 17. This is what you have seen in the earlier class, right? If it is in 9's complement. What about if it is in 10's complement? 45 base 10. This is 38. Right? 9's complement plus 1, 38. So you are going to get again 83. 83. And from 99 you are going to subtract, you are going to get minus 70. Minus 70, right? Fine. Take out the case for 62 45 base 10, where I am trying to perform some kind of subtraction. Again, you need to have the value called 12 7, and you need to have the positive 17. Right? How we are going to do that? 62 base 10, complement of 45 is 54. You are going to do that plus 6. You are going to get 116. As you are trying to get overflow, or I can call it as carry, you are going to simply add that as here 17 base 10. 17 base 10, right? Assume that it is tens complement. If it is tens complement, what will happen? 62 and 55. You are going to get 117. You are going to simply discard this carry. Right? This is what we have seen in the earlier class. Right? Fine. The same thing what you are observing, 45 base 10 plus 62 base 10. What is the result you are getting? Plus 107 base 10. Right? So you are not a, you not only can do with help of the respective number system, you can able to finally convert it into binary number system. See, finally your system is able to understand the machine understandable format, that is binary number system. Right? We can able to do that also. Right? Try to observe. I am trying to do it in 2's complement. Can I do it the number 45 in 2's complement? What is the advantage of 2's complement? I can able to store either positive numbers or negative numbers. Right? If it is going to start with 0, what is the meaning of this one? In 2's complement, number is positive. In 2's complement, one represents negative. So I can represent both positive numbers as well as negative numbers in 2's complement or 1's complement also. Right? So what is the value of 45 in 2's complement? Right? What you can do, simply first try to write the binary number of 45, try to perform 1's complement, then try to add plus 1. Or what is another solution? I have given one formula, minus 2 power n plus 2 power n minus 1 plus 2 power n minus 2 and so on 2 power 0. Right? So you can directly understood that this is positive number. I can write as 0. It is 0. And 32, you should not write 16, 32 and 8, 40, 44, 0, 1. This is 2's complement of the number 45. Is it okay? Try to think. If you want, you can understood, right? This is see, this class is very important for you. 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. What is the formula for this one? Minus 2 power 6, right? What is minus 0 into minus 2 power 6? 0 only. 0 only. And you are going to sum up all this. 32 plus 8 plus 4 plus 1. You are going to get obviously plus 45. Right? So if you want, you can do like this. What is the basic binary number of 45? The same only. But the thing is, you are going to get less number of bits. 101101 is also equivalent to 45. Right? But the thing is, here you have to make it complement once again. What is the complement of this one? This is 45. What is complement of this? 0 1 0 0 1 0. For this, you are going to add plus 1. Right? If you are going to add plus 1, 0 1 double 0 double 1. This is what? Minus 45, not plus 45. Minus 45, right? Okay. You can just calculate it. Okay, fine. Try to think this one. This is plus 45 in 2's complement. What about this plus 62 in 2's complement? 0. All ones, I think this one. Or some other. See, once the concept is completed, you will get the idea. Don't worry. What is the addition? This one, 1 1 1 0 1 1 1 0 1 1. You are going to get 1. What is this total value? You are going to get around negative number. Why I am saying it is negative number? Because at the end you got the 1, right? So try to calculate fast, right? This is minus 2 power 6, means minus 64 plus 32, 8, 2, 1. Calculate this one. 43. If you are going to remove, total you are going to get as minus 21. But what is the result you have to get? What is the result you have to get? Plus 107. So here try to think. I am simply adding 1 0. I am simply adding 1 0. Now try to calculate. If you try to calculate plus 0, 0, are you going to get the plus 107? Yes. You are going to get. Okay, fine. So for timing, try to think this one. And take out the one more number. 45 base 10, 62 base 10. I am trying to perform subtraction. So what is 2's complement of 45? 0 1 0 1 1 0 1 1 0 1, and 62 2's complement. 62's complement is what? 0 4 1s 5 1 0. 0 5 1 0 is what once again? Is it negative 62? No, it is plus 62. You have to have minus 62. What is minus 62 here? See, if you want to get minus 62, can I add 1 here? See, you have to calculate, ma. Without calculation you can't get. Right? How we are going to get minus 60? See, try to calculate 62. 62 is so this is 62. Can I say this is 62? 0 5 ones followed by 0. For this, if you are trying to calculate 5 zeros, 1 1. For this, we are going to add plus 1. You are going to get 1 triple 0 0 1 0 is the complement of 62, meaning that minus 62. Right? Try to add 1 0 0 0 0 1 0. Now try to add. What you are going to get? 1 1 1 1 0 1 1. Right? What is the value you are going to get again? Right? This is minus 62 and plus 32 plus 8 plus 4 plus 3 plus 2 plus 1. Try to calculate 40 47. If you remove the 47 from 62, what is the value? This is 64, right? What is the result you are going to get? Minus 17. Minus 17. So is this result we are expecting or not? In this particular situation, is this result we are expecting or not? Because 45 minus 62 is 17 base 10. That is minus. Are you getting the result? Yes. Here in this particular situation, you are getting the result. So there is no problem here. Right? So try to think one more situation. I mean, you can able to do this processor also. 62 base 10, 45 base 10. I am trying to perform subtraction. What you can do? What is the value of 62 in 2's complement? 0 5 1s 0. So this you have here. What is 45 in 2's complement? So I think this is only for 45 in 2's complement. This is 45 only. For this, we are going to complement it. See, 0 1 0 double 1 0 1. For this, if you are going to make complement 1 0 1 double 0 1 0. If you are going to add plus 1, you will get like this, right? Try to do this 1 0 1 double 0 double 1. Try to calculate 1 1 0 1 0 1 0 1 1 1 0 1 0. What is the value you got here? The result is in 2's complement. When the result is in 2's complement, what you have to do? What is this value? 1 represents minus. So are you getting the minus or not? Yes. But try to calculate. This is now minus 128. Minus 128. And then this is 16. 16. And this is 1. So if you remove 17 from 128, you are going to get minus 1 1 triple 1. Anywhere we did mistake? Ma? So what is the result you need to get here? See, this is minus triple 1, right? This is minus triple 1 base 10. This is okay. But if you observe here, this 1 represents what? 16. This 1 represents what? 1. 16 plus 1 is what? 17. What is the meaning of this one? Here you can simply avoid this consideration. So that, are we getting 17 base 10 or not? 17 base 10, right? Try to think one more case. Minus 62 minus 45. What is minus 62? I think this one. 1 4 zeros followed by 1 0. This one is minus 62. Minus 45 is this one. 1 0 1 double 0 double 1. Try to calculate 1 1 0 1 0 1 0 1 0. So what is the result you need to get here? So if you are able to calculate, you will get the answer. That is minus 128 plus 16 plus 4 20. 20 plus 1 is 21. If you are going to remove this one, you are going to get minus 107. Minus 107, right? So meaning that is our result is getting or not? Minus 107. But here the question is, sometimes we are going to consider this overflow, and sometimes we are eradicating this overflow. Sometimes we are going to add this 0. Sometimes we are not going to add anything, right? That is our question. So why it is happening? So it should not happen, right? As a human being, we can able to understand. But what about the system? System can't able to think right like this. So we have to make some procedure where you have to generalize everything. If you are going to give any kind of input, it has to process it. That is our requirement, right? So take out one more number. For example, I am trying to give the numbers like minus 8 and minus 4. Minus 8 minus 4. What is the result you need to get? Minus 12. What is the 2's complement of minus 8 in 2's complement number? 1 triple 0, right? Minus 2 cube plus 0. 1 triple 0. Okay. What is 2's complement of minus 4? 1 1 double 0. Right? So if anybody not understood, try to observe. This is minus 8. It is plus 4. Total you are going to get as minus 4 only. Okay na? See why I am getting this minus 4. Minus 2 power n plus 2 power n minus 1 so on. Right? Try to add now 0 0 1 1 0. What is this entire value? minus 12 only. Why? Because this is minus 16 and this is plus 4, total is 12. But here the thing is, we are trying to consider the extra bit 1. If you are not going to consider extra bit 1, it will be plus 4 only. But we need to be in a situation where we have to tell to the system that you have to consider this overflow also, right? For that, what you have to do? See, if you are not going to consider this overflow, what is the result you are going to get? You are going to get plus 4, which is definitely wrong answer. Wrong answer, right? So meaning that, so at what situation you are going to get the correct result? When you are trying to give the system to the 4-bit number, system is going to give memory space for the result also 4-bit number. But we need to tell to the system in a position that please try to add one more bit so that result will be correct. Right? So we need to identify a situation where overflow is happening. What is the meaning of overflow? So it requires extra bits to store the data. Then the system will get the actual data, right? So if you are going to have only 4 bits, it is not sufficient to store the data. That is why you are getting the incorrect result. So if you are going to tell to the system that there exists a overflow, so please add one more memory location. So this one won't be lost. When one won't be lost, your result will be minus 12. Right? So try to think, when you are going to add two negative numbers, what is the result you are getting? Basically, in terms of system, a positive number you are getting, right? So don't worry about this one, because in terms of system memory, if you consider there is only 4 bits of memory space. So when you are trying to add two negative numbers, you are getting the result as positive. At that time, you can consider it as overflow occurred. So this is one condition where you can inform the system, so that system will allocate one more extra space. Or you can say in other terminology, there exists a carry. When you are trying to add two negative numbers, if carry generates, there exists a overflow. So try to think one more situation. For example, minus 6 plus 6. What is the result you have to get? 0. What is the 2's complement of minus 6? Right? So if you are unable to calculate it, try to 0 and complement is 1 plus 1. So what is directly you can tell? 1 1 0 1 0. Very good. 1 0 1 0, right? This is minus 8 plus 2 minus 6 only. What about plus 6? 0 1 0. You are going to get 0 1 0 1 0 1 0. What is our result? We need to get 0, right? So at this situation, if you are not going to consider this carry, what you are going to get? Are you going to get the result or not? Yes, right? So at this particular point of time, you should not consider the carry. Meaning that, can I say that you have to indicate that there is no overflow to the system. When you are saying that there is no overflow, system is not going to allocate extra memory, so that our result is correct. So when you are trying to add one negative number and one positive number, even carry generated, you can say that there is no overflow. Why there is no overflow? If I am going to give that indication, the system will think that you should not allocate extra memory space. When you are not allocate extra memory space, this one automatically discarded, because there is no enough memory space is there, right? So that is the reason, right? Try to take one more example. For example, I am trying to take two numbers, plus 7 and some other number like plus 9. What is plus 7 in 2's complement? 0 triple 1, okay, and plus 9 is 1001. Try to think, this is 10 10 10 10 10. What is the value you need to have? 16, right? So if you consider total, is it a 16 or not? Yes. Meaning that here there exists a overflow, meaning that you have to consider that extra bit also. If you are going to consider extra bit, you will get the result. So then what you can tell to the compiler, when you are trying to add two positive numbers, see, I am trying to think about worst case. When you are trying to add two positive numbers, if there exists a carry, you have to tell to the system that there is a overflow, meaning that it is going to allocate extra memory space so that you are going to get store that number 1 or number 0. See here, I am getting certain question. What is 1 followed by 4 zeros? It is minus 16, right? It is minus 16, I think. Am I right? But what is required? You require plus 16, right? So can you cross check once? 7 is 0. See here, I have written 9 is what? Is it 9 or minus 8? Sorry, minus 7. Minus 7. That's the reason we got the wrong result, right? So if you have to make it as 9, what you have to do? This is 0, so I can make this as also 0. Why you are all silent? So now your result will be correct. Try to think 1, 1, sorry, 1 0, 1 0, 1 0, 1 0, 1. So 1 followed by 4 zeros, 1 followed by 4 zeros, you are going to get the 16, right? There is no carry generated. There is no carry generated. When there is no carry generated, you don't need to bother about it. No need to bother about it. But we have to think in situation that at the worst case, if there is a carry generation, for example, plus 9 followed by plus 9, plus 9 followed by plus 9, what you are going to get? Now also, I think now you required 18, right? Right, think 0 1 0 0 1, no problem. 0 1 0 0 1. So you are going to get 1 0 1 0. So this is 1 0 1 0 0 1 0. Right? Now think. Now point here is you got the result as 1 0 0 1 0. 1 0 0 1 0. What is the meaning of this one? In 2's complement. This is minus 16. This is plus 2. That is minus 14. Right? Is it the correct one? No. At this time, what you have to tell to the compiler? You have to add 1 0. You have to add 1 0. If you are going to add 1 0, this will be plus 16, this will be plus 2. So your result will be plus 18. The same case here also. When you are going to have this number, it is minus 16, not plus 16. So you can tell to the compiler that 0, then it is plus 16 only. Right? Meaning that when you are trying to add, two positive numbers, when there is no carry or when there is a carry, you have to tell to the compiler that there is an overflow. When you are trying to say that it is an overflow, what the system will do? It will add extra memory space so that by default it will get 0. 0 means by default it will get as a positive number. Okay, fine. So these are the 3 cases that you have to remember. Right? So you can, if you want, you can just apply the same case for the earlier examples also. Right? Try to think when I am trying to add two numbers. So I think these two numbers are what? 2's complement, right? These two numbers are 2's complement. In 2's complement, if you are going to add two positive numbers, you are going to get carry or may not get carry. You have to add it as a overflow. So that means you have to generate 1 0. So that's the reason you got plus 1 0 10, 1 0 7 base 10. Right? So when you are trying to perform one positive and one negative, what is the rule I have defined? When there is a carry, you have to say that there is no overflow, meaning that the extra generated bit should be discarded. Right here, you are trying to add plus 45 and minus 65, minus 62. There is no carry, so you have to go with the normal procedure. Here you have to think minus 1, minus 62 and minus 60, minus 45. Here we are trying to consider one extra generation that should be considered, because I am saying that is overflow. Then only you will get the result, right? So if you follow these three rules, you will get a correct results. Okay, now. So think about this one. So means here, when you are trying to solve any particular kind of these problems, you are trying to check always whether the first number is negative number or not first, and second number is negative number or not, and in the result also you are trying to check whether the number is negative or not. Meaning that total you are trying to check for three comparisons for to get the result. So in order to define whether there exists overflow or not. Okay, now see, finally what you have to tell to the system, whether you need to append one extra bit of memory or not. In order to append extra bit of memory, you have to always think about these memory locations. First number is negative, second number is positive, or negative negative, or positive negative, positive positive. Followed with the result you have to compare. Meaning that three comparisons are required. Instead of this, what we can do now, we can simply take one analogy. I am trying to take four digit number A1, A2, A3 and A4, B1, B2, B3 and B4. If I am trying to add these two, right, both are from the 2's complement numbers. So the simple logic is, when you are trying to perform the addition of A3 and B3, if it is going to generate some carry, I can call it as carry in. So that carry in will be added to what? A4 plus B4, and it is going to produce some result, right? That result can contains carry out also. C out means carry out. So with this conclusion, I can able to define when C in is equal to C out, I can able to define one as overflow occurred or not, or when both are not equal, I can define overflow or not. Try to take out this example. This example. I am trying to add two negative numbers. This is okay. Here, when I am trying to add the last two numbers, 0 and 1, I am going to get 1. Is there any carry in provided? No. Means it is 0. And when I am trying to add 0 plus 1, what you are getting? 1 carry, that is 1. Right? So carry out is 1, carry in is what? 0. When carry out is 1, carry in is 0. What is the meaning of this one? Overflow occurred. So simply that logic can apply, right? When carry in and carry out not occurred, so there exists overflow. And whereas coming to this one, no overflow. So now you can able to reduce the hardware performance. I mean processing, because in the earlier things you required three comparisons whether overflow or occurred or not. One is first number is negative number or not positive number, second number is negative number or positive number, and the result is negative number or positive number. You have to check. So based upon these three conditions only you are going to define overflow occurred or not. But in this particular case, you are going to simply define checking of these two parameters. First one condition is if this is one condition, and second condition is this. With help of these two conditions, I can define overflow occurred or not.